So for the fixed point iterations method, we have the nonlinear system fxy equal to 0, gxy equal to 0. Then using fixed point iteration method is very easy. Mean is you can express x either from the first equation or the second equation. If you express x from first equation, then you need to express y from the second equation. So since you let's say you express a x for example just now our example, where is it, this one the fxy is x squared plus y squared minus 8x minus 4y plus 11. You can express the x either you from the quadratic term or from the linear term, or you want to take it from the quadratic term from the second equation or the linear term from second equation. So in total you got 4 choices here. So how to choose the correct x equation or correct y equation is up to the luck. Mean x you got 4 choice to choose there. If you choose x from the first equation, then you choose y from the second equation. That's why from initially fxy equal to 0, when you express x as title, so x, let's say you express x from the first equation here, then you have the x so the other term, so you got x squared will equal to y squared, mean minus y squared, this will be plus 8x plus 4y minus 11 squared. So you take the square root. So you see, x will be another new function. That's why what we said, you have a nonlinear system. First step, you express x at a new function, let's say hxy. If you express x from the first equation, then you express a y from the second equation, or the other round. So y is a function of kxy. Second step, you check for the convergence. But sometimes if you don't check, you may directly plug in into Excel. If they converge, the solution will mean the number will be smaller and smaller. It wouldn't get bigger and bigger, or it wouldn't get not a number there. So then or proper step, you will check. Second step, check for convergence. Mean you need to find from x equal to a function of h x y, you can find del h del x. And then you differentiate h respect to y. Now differentiate k respect to x, k respect to y, similar to you find the Jacobian metric. But each k item you take the modulus and you evaluate your del h del x, del h del y, del k del x, del k del y at the initial point. And if the modulus of del h del x at the point x naught y naught plus del h del y at the point x naught y naught less than 1, and del k del x at the point x naught y naught plus the modulus of del k del y at the point x naught y naught less than 1, then we said the formula that you use is will can lead to the converged solution. Then what you need to do is x at the left hand side we put iteration I plus 1, and then xy at the right hand side you put xi yi. Mean given x naught y naught, then you can find x number 1. So from the function kxy, y here you put a yi plus 1. So the xy you put as a xi yi. So mean given x naught y naught, then you can find y number 1. Then the process is repeated until the vector xi plus 1 minus xi less than epsilon. Mean with x naught you get x number 1. Then you check whether the modulus of x number 1 minus x naught less than epsilon. If yes, you stop, the root will be x number 1. Otherwise, repeat the second step, get x number 2. X number 2, you deduct x number 1. See whether less than epsilon. If yes, the root is x number 2. Otherwise, repeat until you find the roots. This is a procedure. This one actually similar. And then we use back the same example that we solved just now. Now we try to solve using the fixed point iteration methods. As I said, there's no rules or no guideline to guide to choose the x either from from which one, is it x squared term Okay, quadratic term or linear term from first equation or the quadratic term or the linear term from second equation. No guidelines. It depends on your lucks. So in this case, which one that you want to choose? Okay, which one you want to try to express
Linear.
x? Which one?
Uh, 8x
8x
minus 4y.
Okay. You want to choose, you want to x from this term, negative 8x. Is
Yes, correct.
okay. Then mean this term you bring to the other sides. So you got the, in the x, initially you got 8x to x squared plus y squared minus 4y plus 11. Mean negative 8x bring to the other side. So you just want 1x, right? Then you, okay, this one you divide by 8. Okay. So this is what they label as a h. F, G. Let's say this is a h, x, y. Okay, if I choose x from here, then y you must choose from, okay, second equation. So it's only one choice. One choice. So y, this is y squared. You focus this one. So the other term bring to the other side. So will be initially you got y squared. So it's negative x squared plus 20x minus 75. Okay, you want y, so you take the square root. Okay, this is what we call h k, kxy. Okay, so if you follow the second step, you need to find your del h del x. Mean differentiate h respect to x. So you have only 2x divided by 8, because these are all 1. 2x divided by 8, so you have, okay, x over 4, right? And then del h del y. Differentiate, okay, the function h here respect to y. So you have here 2y minus 4 divided by 8. Can I write here? Let me see. And then del k del x. This one you got square root. Okay, square root is power half. So for differentiation, power you bring, okay, front, so you half. And then the power half will be minus 1. So you got negative x squared plus 20x minus 75 power negative half. And then you del x, okay, the function inside square root. So you have negative 2x plus 20. Okay, or you simplify it, half simplify with here, you got negative x plus 10. Negative half is actually the, bring down the square root at the denominator. So similarly, when you find del k del y, okay, del k del y, we don't have y, this will be 0. Okay, and then easy, I will choose, okay, here you want to find the root at the bottom. We may pick find 0 or find negative 1. So for easy calculation, let's say I pick the initial value 5, 0. I put y0, easy to calculate. Then I calculate del h del x at the point x is 5, y is 0. Oh, this value is greater. See? When I put x is 5, 5 divide 4 is 1.25. already greater than, okay, already greater than, when you add up, okay, follow the, okay, criteria, you add up, the value should be less than 1. But this cell, the value is already greater than 1. So mean, okay, when I check this one is already greater than 1, suppose it won't converge. And to check, you can plug in the formula. Okay, means step 1, I check the first value only. I see this value is already greater than, okay, okay, already greater than 1. So means suppose the formula, it won't get the converged solution, mean it won't find the root. Either you get, normally
Okay.
when you have a square root, it's either, in the case the number, the number inside the square root is negative, so you get a not a number, or either the function that you obtain, you get bigger and bigger value, it goes to infinity. So that's what we said not converge. Okay, to check that, let's say we can use, again we go to Microsoft Excel. Okay, because suppose, okay, this one you can go to another sheet. Okay, just now the formula that we get it from the second equation. Okay, we get the equation from the second equation. Rewrite again. Okay, you just now you get it from this term and this term. So your x is x squared plus y squared minus 4y plus 11 divided by 8. Your y is square root. This is negative x squared plus 20x minus 75. Okay, and then what you need to do is, okay, left hand side you put it I plus 1. So right hand side this xi, yi, this yi. So yi plus 1, this is I, this is I. Okay, and then we take the initial, okay, value. Okay, okay, I just need the I, the x, and the y. When I 0, okay, x naught, let's say I take 5, y naught, let's say I take 0. Okay, then I is 1. So mean with x naught, y naught, I'm going to get calculate x number 1. Okay, using the x formula here. Okay, which is a x naught squared plus y naught squared. So you click x naught power 2 plus, okay, y naught power 2 minus 4 times, okay, y is c10. Sometimes you cannot click, then you type in c10 plus 11. Okay, for divide, okay, in Excel limitation, you cannot show like the natural display in mathematics. So you need bracket. Numerator, you have more than one term, so make sure bracket. So force that, okay, the bracket, okay, mean the expression in the bracket will be performed first. Now divide is a backslash, divide by 8. So make sure a bracket. If you don't put bracket, they only will take 11 divided by 8 only. Mm. So mean what it mean, you key in x naught 5, y naught 0, uh, we obtain x number 1 using this formula. Okay, and then using x naught, okay, this is y is depend on the x only. So y square root is equal, and then sqrt. So any function in Excel, make sure you open and close the bracket. So square root, you got negative x power 2 plus 20 times x minus 75. Okay, open close the bracket. Okay, and then since x1 y1 is formula, you want to only 4 decimal place. Okay, you want to calculate the absolute error for x, and then the absolute, okay, error for the y, okay, equal ABS is absolute value. Take x number 1 deduct x number 0. Mean 4.5 deduct 5, so you get negative 0.5. We take the absolute value will be 0.5. Okay, that's what mean absolute. Okay, so I can copy paste. Because the Excel, okay, why we can copy it down? We can copy it to the left or right. They are okay have the relative columns, okay, property. Mean here you see the formula. Initially you take the absolute B11 minus B10. Okay, when you copy it, the pattern will be follow. I take C. Mean okay, initially formula column B, you copy next column B become column C, row, okay, value maintain. Okay, when you copy it down, okay, copy it down, okay, column maintain but row increase. Okay. You see the formula initially is B10. Okay, BC maintain, but when you copy it down or copy it out, okay, you copy it down, the row, okay, number increase. You copy it up, row number decrease. You copy it to right hand side, the column increase. You copy it left hand side, column decrease. This is relative column and row, okay, properties in Excel. Okay, what I mean, okay, this one is without checking the convergence criteria. And suppose we check convergence criteria. Just now I said I check number 1 only. When I see this value is bigger, I said this is not converge. So now I'm going to show you what is meaning of not converge. Okay. You see the value bigger and bigger, it won't converge. Huh? See the value bigger and bigger. Now quite big. So the value is bigger and bigger. Okay, this is what I mean not converge. Bigger and bigger, and from the graph we know the value x is actually between, okay, between where? 4 to 6 only. Y between 0 to -2, but the value they obtain bigger and bigger. This is what we call, okay, not converge. Mean you cannot obtain the solution. Okay, not converge, okay, or another word is we call diverge. Okay,
So we have to choose another equation, Doctor.
yes. So okay, how
Okay.
to choose? No idea, no guideline. So you are not okay, not lucky. You choose x from here, you cannot get. So you want to choose here, or you want to choose x from here? The second equation. Which one?
Uh, the first one, right? X squared.
From the x squared.
Okay.
Okay, you want to choose. Okay. Okay. Okay, we duplicate another sheet. Move or copy. Okay, we choose okay another one. This one delete. Okay, let's say you choose okay x from the quadratic term from the first equation. Okay, you want to try this, Then y again from you choose x from here, y must be the other equation. Then from here, so you have initially x squared. So y squared, okay, bring y, I mean all the other term, okay, bring to right hand side. So you have negative y squared plus 8x plus 4y minus 11. Okay, you want x only. You want x, So take the square root. Okay, this is so-called the h, Then y okay, similar to just now. Okay, square root negative x squared plus 20x plus 75. This is a kxy. Okay. If you want to find the del h, del x, okay, differentiate respect to x, square root, so you got power half. Okay, and then power half minus 1 for mean, okay, recall back, you ddx u power n and u power n minus 1 du dx. So okay, power half, okay, minus 1, so power half minus 1, negative half. So negative y squared plus 8x plus 4y minus 11 power negative half. And then you ddx, mean you ddx or you del del x negative y squared plus 8x plus 4y minus 11. So this one you have 8, mean, okay, del del x, this time we got 8 divided by 2, so total is 4. Then the square root at the bottom, negative y squared plus 8x plus 4y minus 11. Mean here 2 and this one. This one, okay, del del x, 8x, you got 8. So 8 divided by 2, you get 4. So this is a del h del x. And then we find del h del y. Okay, del h del y is only you change this part. This part you change to del del y. So differentiate respect to y. This one you have negative 2y plus 4. Then initially we got divide by 2 here. And then the square root at the bottom. Negative y squared plus 8x plus 4y minus 11. This is del h del y. Then later on we find the del k del x. Okay, differentiate respect to x, we have, okay, half, and then as just now, okay, power half, okay, become minus 1 become power negative half, okay, which is a square root at the bottom. So negative x squared plus 20x plus 75, and then you differentiate respect to x, you have a negative 2x plus 20. So you got negative 2x plus 20. Okay, and your del k del y, y here only k function of x, so del k del y equal to 0. Okay, we check whether your del h del x, okay, 0. Okay, when y is 0, oh, you got the very, when y is 0, you got square root negative 11. This is not a complex number. Okay, we put another value. Why? We put 5 negative 1. Oh no, correct. You still got 8x. Okay, 4 divide by y is 0, y is 0. 8 is, okay, 8 is 5. Okay. Since you in Excel, you can calculate this value, okay, using the Microsoft Excel here. Equal 4 divide sqrt. Okay, y is 0. Y is 0 means 8 times 5. 40 minus 11. So 40 minus 11. I want to see the value. Oh, missing one more. Missing square root. Okay, one bracket, and okay, denominator. Okay, at the denominator, one more bracket. Okay, so the del h del x at the point 50, you get 0.74278. Then I would like to calculate the del h del y. Okay, del h del y at the point 50. Okay, y0. Okay, y0. So you plug in y0, so we got 4 divided by 2. So I got 2 times divide Okay, the bottom the same number is a SQRT Y0. So 8 times 5, you got 40 minus 11. When you see these two values, 0.74278 add up with here, also greater than, okay, this one, greater than 1. So when check, okay, the first one is greater than 1, I suppose, okay, it will get diverge solution. Okay, and then if you want to proceed to, let's say, del k del x, but this one, because this one you add up already greater than 1, so I don't proceed to del k del x and plug in the 0.50, but show you in Excel, see whether if we change the, okay, the second time the formula, okay, suppose using the convergent criteria, it said, okay, the answer should be, okay, diverge. Okay, let's try it now. So now to click in Excel, so mean the formula that you choose just now, so left side you put I plus 1, I plus 1. Right hand side is I. So mean with x naught, y naught, you calculate x number 1, y number 1. Okay, so the x, okay, again the formula is square root SQRT, okay, negative y, okay, when I 0, so y naught squared. So click y naught power 2 plus 8 times, okay, I0 is x naught. Click x naught. Sometimes you hide, then you type x naught column B, B10. B10 plus 8 times y is C10 minus 11. Okay, the y formula same with, okay, the first choice. Because, okay, first choice we choose x from linear term. Then y only one choice from the second equation. Second choice we choose x from the quadratic term. Okay, that's why the y formula same. Then okay. So since we already changed a new x formula, you can just recopy it. Also, you see, second choice also no luck. Also bigger and bigger. So that's why, okay, the convergent criteria, these two add up greater than 1. First time, okay, this one, first try the first value already greater than 1. So I stop. Okay, so in this case, then move a copy, a copy. This one also erase. Okay, this is a third choice. Which one that you want to try? Try x, you have to try from the second equation. You want linear term. Okay, which one?
I'm not sure.
Linear. Try linear. Linear, you don't have the square root easy.
Okay.
You try linear first.
Whichever is
Uh,
easiest.
Easy to differentiate. If you got square root, then you differentiate. You got the square root at the denominator.
Yes.
We try linear term. Okay. So this round I try x from here. So okay, so negative 20x I bring to the other side. So you got 20x, x squared plus y squared plus 75. You want one x only, then divide by 20. Divide by 20. Okay, this is a function h. Okay, so I choose x from the second equation. I choose a linear term. So y easy. I also choose a linear term lah. Y, you got linear quadratic. I try from linear term. Then negative 4y bring to the other side. You have 4y x squared plus y squared minus 8x plus 11. You want one y only, then divide by 4. Divide by 4. Yeah. So this is a k x y. Okay, and then we will choose del h del x. Okay, differentiate function of h is here, the right hand side here, del h del x. So you got 2x divide 20, or x divide by 10. Then you find del h del y, 2y divide 20, or y over 10. Okay, you can calculate the value. Let's say del h del x, we choose the initial guess 5, 0. So x is 5, so 5 divided by 10, so we obtain 0.5. Then del h del y at the point 5, 0, you get 0. So when you add up here now, this is 0.5. Let's see the modulus. Del h del x at the point 5, 0, the absolute value is 0.5, and then the absolute value of del h del y at the point 5, 0. 0.5 add up 0, you get total 0.5 less than 1. So the first case criteria is satisfied. Yeah, this one satisfied. Let's check the second. Okay, the second one, we have the y. And from here, I find del k del y. Del k del y have 2y divided by 4. Okay, here differentiate y squared, 2y divided by 4. Find x first. Okay, del k del x. K is a function x squared plus y squared minus 8x plus 11. Then you find del k del x. So 2x minus 8 divided by 4. And then del k del y, you got 2y divided by 4. Okay, plug in the value 5, 0. Plug in x is 5, y is 0. So x is 5, okay, 2 times 5, 10 minus 8 is 2. 2 divided by 4 is 0.5. And then del k del y, 5, 0. When k is 0, I get this is 0. Okay, that's why, okay, you have the del k del x at the point 5, 0. The mean absolute value for del k del x at the point 5, 0 add up with, okay, del k del y at the point 5, 0. Okay, and we get 0.5, which is less than 1. Mean the convergence criteria in this case is satisfied. Okay, so this one, so the convergence criteria must both, okay, both lines satisfied. Okay, if satisfied, then you obtain the iterative formula. Okay, iterative formula, very easy. From the formula you write down just now, left hand side put I plus 1, left hand side I plus 1, right hand side this I. So mean with x naught, y naught, you can calculate y number 1, x naught, y naught, you calculate x number 1. Okay. So the error, okay, column error x, error y, you can maintain there because the same. Okay, I just need to change the formula for x. Okay, formula x. So x naught y naught. And okay, numerator 1, 2, 3 terms. So bracket. Okay, when I equal to 0, x naught squared. So click x naught, which is 5 squared power 2 plus y naught squared plus 75 divide 20. So okay, you get 5. And then with x naught, y naught, you can calculate y number 1. Okay, mean plug in, okay, x naught, okay, y naught into the yi plus 1 formula. So you have what? X naught squared plus y naught is C10. Sometimes you cannot click, you type the location C10 power 2 minus 8 times x. X is B10 plus 11. So close the bracket and then divide by 4. Okay. And then okay, copy down the formula because we have a new formula. Okay, so the error, let me put to 4, display to 4 decimal place. Here I didn't round it, so only display. Okay, so you see at iteration, oh, okay, copy down, increase at here. When I equal to 8, I equal to 7, you cannot stop, but because error of y still greater than epsilon. 8 also, 8 still greater than epsilon, 8 cannot.
So 9.
Yes, iteration 9. We can stop at iteration 9. Okay, and then when you stop, please write down your stopping criteria. And this is what we call converge. When you converge, okay, you see the number, the focus zoom in. Mean we zoom into the, okay, mean to the root. That's what we call converge. And the error you see bigger, smaller and smaller. If just now you see error, okay, big, not the number is bigger and bigger. This is what we call diverge. Okay, or sometimes, okay, you see this one, the error so big. Or sometimes you can get NaN, not number. Because especially if you have a square root formula, square root, sometimes the value inside square root is a negative, so you get not number. Because here you can calculate real number only. Complex number cannot.
Oh, okay.
And the root is actually our root. Here we calculate only the real root. Complex root cannot calculate. We only calculate the real root. Okay. So, and when you find, okay, when you find the solution, you have to write down. If you don't write down, we'll deduct you the conclusion marks there. You have to write down since, write down the reason. Okay, mean you can put up straight away, modulus. Okay, vector x consists of the little x and little y. Vector x number 9 deduct x number 8, okay, less than epsilon, which is 0.0005. Okay, therefore you can put therefore the root the root is approximately x number 9. This vector x number 9 is equal to 5.0651 negative 0.8046. Okay, each method we have a slightly different answer. If I put, let's say 50 here, see this one, 5.06, okay, 5.0652. If you use here, 5.0651, a slightly different, because different method. So the answer is slightly different. Okay, and Newton method is quite easy. to find another root by changing the initial condition. Okay, however, okay, if you want to find this root on the top, let's say if Newton method you just change initial condition, okay, but fixed point iteration, if you change initial condition, okay, you will get back, okay, normally get back to the same root, or it couldn't get. Mean another root, you have to find another, normally another formula. Okay, let's say here we want to find this root. Let's say I put 6 4, you plug in to here 6 4, see whether you can get another root. So you see 6 4, you okay, if you okay iterate it, I think you get back, to the not the first root, 5 mean with okay, if Newton's, you see Newton, if I change 6 4 6 4, okay, you get okay, if I plug in 6 4, I can get second root, which is 6.5348, 3.6045 here. But in fixed point iteration, if you change another initial condition, okay, you still get back to the first root that you put in the formula. And then okay, if you want to get this root, you have to try see other formulas. So compare fixed point and Newton's. Newton will be easy and flexible, because even though look like a bit tedious, you have to find the Jacobian vector f. Okay, you find the delta x. Okay, delta x using okay the formula just now. Negative. Okay, the multiply mmult is multiply the m inverse is okay, the find the inverse of your Jacobian and then multiply with vector f. Okay, even though a bit tedious, but once okay, the solution is okay, done, you can just change a new initial condition to obtain a new root. Okay, fixed point. Okay, the formula is easy. You try, easy to plug in, but not easy to get the correct formula. Like here, we try 3 times, then only we get the correct formula. And then, okay, the correct formula for the root at the bottom not necessary can be applied to obtain okay the root okay on the top, because we try to put in okay just now put it 6 4, it still okay converge back to the root at the bottom. So to get the root on the okay top, you have to try again. So okay, even look like easy, but not easy to get the correct formula. This is a fixed point iteration methods. Okay, before we end the lectures, you can also use okay the Excel solver. Okay, the Excel solver mean the same okay the same question. Now we are going to using solve it using the Microsoft Excel solver to obtain okay the root at the bottom and on top. Okay, what you need to do is actually okay here you have the first row, key in the this one, indicate the label. What you need to do, x y. Okay, fxy is the first nonlinear equation. Okay, d is a column d, gxy is the second nonlinear equation, and find the sum of squared of the okay fxy squared, which is c2 squared plus d2 squared. And we are going to minimize it to 0. Okay, by vary the value of x and y. So my okay sum of squared is at the e2. So I set the objective e, oh so wrong, this will be e, not ep, e2. Set it to 0, minimum value of 0 by vary the cell, oh also wrong, a2 b2, and then you click solve. When you click solve, and this cell will be varied, and when you stop it, this will be the root of the x and y. Okay, so this we go to Microsoft Excel, going to copy this equation, paste it here. Okay, what you need to do, you have the column x, column y, the f xy, your g xy. This is a sum of squared. Sum of squared of fxy squared plus gxy squared. Okay, let's say we try the first root is 5, 0. Put in 5, 0. Okay. Okay. Again, key in the fxy x squared. So x plus y squared minus 8 times. This is a x minus 4 times y b6. B6. Okay. Plus 11. So you get negative 4 gxy x squared plus, this is a y squared minus 20 times x plus 75. Okay, sum of squared. Okay, the fxy squared plus gxy squared. Okay, then what we want to do, so E6 solver. Okay, if you cannot see the solver in your Microsoft Excel, you go to File, Options, Add in, go, check on this solver add in. Okay, then we'll see solver, okay, solver, okay, apps there. Okay, and then you click the solver. Okay, mine is a Microsoft Office 365. Microsoft Office 365. So the layout a little bit different. Okay, the layout, but yesterday when I try, it's still the old, but today suddenly changed to the new one. Okay, the old one will be like this layout. Set objective. So click the cell of the objective, which is the sum of squared. We want to minimize it to 0 by vary the cell, okay, x naught, y naught, and then you just solve. Okay, and now this is a new layout objective. So click my objective, this cell. Cannot click. Minimize. Cannot click. Okay, dollar is okay. Okay, the cell is E6. E. Okay, capital E or lowercase e doesn't matter. So E6 is a value of the sum of squared. I set it to minimize it to 0. Okay, variable. Suppose I can click. I cannot. I type cannot. Then I type. Okay, if your all layout, this one, you select the cell A, see where's the x naught, y naught. Then you select that cell, it will give you that formula. Okay, this one is yesterday I typed but wrong. Should be $A, $2. Okay, so here, okay, x naught is A6. A6 colon. Okay, dollar there is mean I will fix at the cell A6 until be 6. Okay. So you see the objective is minimize E6. Okay, the variable is A6 to B6. Oh, I cannot see at the bottom. Okay, and then how to solve? Suppose bottom I should have the solve constraint model. Different. This one new one. Suppose bottom I got the solve thing, then I can solve it. Or too big. Okay, let me minimize the 100%. No. Okay, set objective is 6. Minimize it to 0. Constraint, we don't have the constraint, the model. Why I cannot solve? Or upload the workbook. So if we use Office, I think 2016 or what, whatever, I think I'm not sure whether it's changed to the new layout. Okay, solver found a solution. Why not show the solution to me? Oh, okay. Okay, already found the solution here. Here. So x is 5.0652. Check back 125. Okay, already said solver found a solution. You see back, okay, now this is a solution. If I to 4 decimal place, 5.0652 negative 0.8045. Okay, check with the Newton. If 50, yeah, 5, okay, this is using Newtons.
Same.
Same, okay.
Same.
Using let's say put here fixed point 50, 50 here, sheet number 5. Oh, when you copied the formula, the formula running, so we want to copy this value, Control C, and then I paste value. Nah, so it won't run. Okay. Here also run because the formula run. Unless the value here, Control C, when I paste, paste value. Because the formula, if you copy paste, it still carry the formula. So carry the formula, the location is different. That's why the value run. If you want to paste the value only, just paste value. Okay. So this is using Microsoft Excel solver. Okay. Now if I change it to, I want to get the top root. Let's say I put x is 6, y is 4. Again, I put x, this value I copy down. This is from the solver. Paste value. Now I change x is 6. Okay, change x 6, y is 4. Okay, again ask it to solve. Okay, solver found a solution. You get here 6.5348, 3.6045. Check with Newton. Change 64. Control C. Okay, make sure I paste value. Uh, So same. So only the
Yep.
fixed point, the top root. Okay, you have to try the formula like what we tried okay just now. So this is solver. This is a new layout. The new layout. Yesterday when I tried, still this layout, but suddenly today change to the new layout. But this one, the cell is E2. So dollar E, the P there, delete it. Dollar E, dollar 2. By changing the cell A to B2. Dollar A, okay, that hash symbol you delete, okay, wrongly type. Dash, dollar A, and then dollar 2. Dollar A, dollar that means, okay, they will take, okay, they fix at the cell A2. So dollar B, dollar 2. This is all layout, and okay, this one is the latest layout. But okay, from this is Microsoft, okay, Office, but I'm not sure because I don't have the, okay, I don't have the Office at say 2016 or other version, so I'm not sure. This is Office 365 latest layout. Okay,